Okay, so for the very first question, we are asked to write and draw the vector whose initial point is at the origin and whose terminal point is what we're given. Now, hopefully we don't make these problems too much more difficult than what they are. Notice they want your initial point to be at the origin, so we're going to start out with an initial point at the origin. And then our endpoint is going to be at the point 5 and then 2. So that's the end of our vector. And so it just wants us to sketch this, very basic sketching. And then it wants us to write this in vector notation. So we do need to make sure we write our vector notation. So there's the first one. And let's see, for part B, we are also going to have the same idea. We are going to have to go start at the origin. We go over 1 and down 4. That's our terminal point. We do connect them. And then it wants us to write this in vector notation, which is going to be 1, -4. Okay, so now let's look at part C. And part C, same idea. Now it might be a little bit easier for us in part C to change -9 over 2. Let's see, that's probably going to be a -4.5. So let's go ahead and put that. We have, and I'm going to go ahead and do vector notation. So -4.5. And 7/2, well, that's going to be, let's see, 3.5 maybe. And we've got our vector notation. And so when we graph this, we're going to go back 4.5 and then up 3.5. And we have our initial point here at the origin, so we have something like this. Very straightforward, just going through and graphing those. Right, so now in order for us to draw our vector v and find the magnitude, we're going to need to go ahead and plot our given points. So we have 2, 2, and that's going to be our P. And then we have 2, 5, that's going to be way up here. And so that's Q. So our vector PQ, or we can call it V, is going to look something like that. Now we need the coordinates of our vector v. We need to note that. So we have vector v is equal to, and don't forget your notation, you have to be careful. And we're going to say it's 2 minus -2. So 2 minus -2, comma, and then 5 minus 2. 5 minus 2. So our vector v is going to be 4, 3. So there's our vector v. Now in order for us to find the magnitude of vector v, that's where we can do our Pythagorean Theorem, or we could do distance formula, however you want to think about it. But it's going to be 4 squared plus 3 squared. So that magnitude of vector v is going to be 16 plus 9, or the square root of 25, which is 5. And hopefully you are recognizing this was a 3, 4, 5 right triangle. So maybe we recognize that. Okay, so moving on to the next one, let's look at B. Same idea for B. We need to plot our 2 points. And so let's go ahead and do that. Let's plot our points. So we have 5, -3. So somewhere down here. And then we have -1, 1. So here's our point P. Here's our point Q. And so if we want to find that vector, we're talking about this vector here. And so we need to go through and find, well, what would be the coordinates of our vector v? And so we again are going to do subtracting. -1 minus 5, that's -6. And 1 minus -3, minus a negative, so that's +4. And now we need the magnitude of vector v. So that magnitude, we're going to have the square root of 6 squared, so 36. You can ignore the sign because when you square it, it becomes positive. And then 4 squared is 16. So the magnitude of vector v, that's going to be the square root of, it looks like 52. And you can leave it like that. I'm not worried about you finding the decimal value or anything like that. Okay, and now let's go over to part C. I'm going to have to do C's below it. I've run out of room. And again, let's work through. We're going to plot our points. So 4, -4. So we have our point 4, -4. And then we have 1, 5. So 1, 5. Way up here's our Q. And so here's our vector from P to Q. And so let's talk about, well, what would be the coordinates of our vector v? Well, 1 minus 4. So 1 minus 4, that's going to give us -3. And then -5 minus a -4, that's going to be -1. And then we need the magnitude of vector v. So that's going to be the square root of 3 squared plus 1 squared. So it looks like we get the square root of 10. Okay, moving on to the next ones. The same idea again here. We're still plotting our points. So let's see. For this one we have vector, let's see, we have 4, 0. So we have our point 4, 0. And then we have -1, -4. So -1, -4. So here's vector P, or I'm sorry, point P, point Q, and we want the vector from P to Q. So it's going to go this direction. And so let's see, from P to Q looks pretty good here. And so let's work out our vector V, the components in it. Well, we're going to have -1 minus 4, so -5. And then -4 minus 0, so -4. And then we need to do the magnitude of vector v. So we're going to have the square root of 5 squared, so 25, plus 4 squared is going to be 16. So that's going to give us the square root of 41. Okay, moving on to the next one. For E, same idea again. So we're going to have, let's see, 5, -5. That's our point P. And then for Q, we have -1, 1. And again, our vector from P to Q. And so our coordinates for vector V, again, -1 minus 5, so -6. And then 1 minus -5, so +6. And then we need to look at the magnitude of vector V. And so the magnitude is going to be the square root, 6 squared plus another 6 squared. So it looks like we have the square root of 72. Okay, and so again, same idea for F. And this time they threw in some decimals at us, oh no. So we have -2.5 and -0.5. So -2.5, -0.5, so there's P. And then we have Q, which is -1.5 and -3.5. So it's down here, there's Q. And so our vectors from P to Q. And let's look at our coordinates for vector V. So for vector V, we're going to have negative 1.5 minus a negative 2.5, so negative 1.5 plus 2.5, so that's going to give us a 1. And then comma, let's see, negative 3.5 minus a negative 0.5, so that looks like we're going to have a negative 3. And then our magnitude for vector v, square root of 1 squared plus negative 3 squared, so we're going to have the square root of 10. Okay, I hope this helps. Moving on to the next set of problems. Here, given the set of vectors, we're finding just these basic operations with this. So let's go through and look, and whether or not you show all your work, I realize some of these problems, these are things you can do in your head. I completely respect that. So let's look at the first one. We need u plus v. So we're looking at vector u plus vector v. So it looks like if we go through and add those two, negative 3 plus 6, so I should get 3, comma, and then for v, or let's see, go ahead and add our second components and we get 6. Okay, so let's see, for the next one we're subtracting, and hopefully when you subtract each individual point you should get negative 9. And then it looks like you're going to get 8 minus a negative 2, so positive 10. Okay. And continuing on with this, it looks like, let's see, 3 times u. Well, 3 times u, hopefully when you work those out, you're just saying 3 times each part of vector u. So you should have something that looks like negative 9, comma, 24. The biggest thing here is watch your signs and watch your notation. And so for part D, you're going to have to go through in a couple of steps here, because you need to say 3 times u and then 4 times v and then subtract those. So let's write in those steps to make sure that we don't mess up here. So 3 times vector u, so I'm going to write this individually here. So 3u, 3 times vector u, well that's going to be the vector, let's see, vector u, so negative 9, comma, 24. And then we're going to say 4v, well, that vector, 4 times vector v, is 24, comma, 4, let's see, 4v, so negative 8. And now we need to subtract these. So if we go through the whole process now of subtracting, well, let's see, that vector is going to be negative 9 minus 24, so that's negative 33. And 24 minus a negative 8, so 24 plus 8, that's going to give you 32. So hopefully y'all got that one correct. Right, and so part E, very similar, all of the same thing again. So let's walk through step by step. 6w, well 6w is going to be the vector 6 times 1/2, well that's 3, and then 6 times negative 2/3, that's going to be negative 4, and then let's see, 1/2 v, 1/2 v, so everything with v we're going to take a half of, so 1/2 v is going to give me 3, negative 1, and then just get over vector u, that's going to be negative 3 and 8. So let's see what we get when we work all of those out. So let's see, we need minus here, so we're subtracting this middle one, and then we're adding the u to it. So 3 minus 3 is 0, and 0 minus 3, that's going to be negative 3. and then -4, and then minus a -1. So -4 plus 1, that's -3. -3 and 8 is 5. So there's that vector. Now this funny notation, remember, if you're finding the magnitude of vector v, that magnitude of this is just another notation. That's the square root of your a squared plus b squared. That's all that is. So we do need to figure out, well, what's going on with this, and then find the magnitude of that vector. So let's see if we can figure out 2u plus v. So 2u plus v. What vector is that going to be equal to? Well, let's see, 2u, so that's going to give me -6, 16. And then I need to add v to that. So vector v is going to be, let's see, 6, -2. And so, goodness, if we add those together, it looks like we're going to get the vector 0, 14. And now I need the magnitude of that vector. So that means I need the square root of 0 squared plus 14 squared. So that's just going to give me 14. So there's my answer to F. Okay, and then G. So let's see what we can do with G. G wants vector v over the magnitude of vector v. So let's see if we can figure that one out. So vector v, and then we're going to divide that by this magnitude here. So I would go ahead and find out, well, what's the magnitude of vector v? Well, the magnitude of vector v is going to be the square root of, let's see, 6 squared is 36, plus 2 squared is 4, so that's going to be the square root of 40. And so if I divide each part there of vector v by the magnitude, well, then that's going to be the vector, it looks like we're going to have 6 over square root of 40, comma, and then we're going to have 8 over the square root of 40. And y'all can leave that just like it is. All right, and now for H, we have u plus v, and I think we found u plus v earlier. U plus v, we did that already up here with this problem, so we know it's 3, 6. So if we knew what the magnitude of that vector is, well, that would be useful. So I'm going to go ahead and do the magnitude of that here. So that's going to be 3 squared plus 6 squared. So that looks like that's going to be the square root of 45. And so if I divide those, then I'm going to get the vector 3 over root 45. And I think I'm out of room, comma, 6 over root 45. And there's my vector. All right, now for vector 4, my gracious, there's a neck. All right, let's look at problem 4. Vector u has a magnitude of 20 meters and is directed due south. So it looks like we're going to have to draw some here. So I have an XY axis, and I'm going to change color so we can see vector u 20 meters directed due south. So I'm going to start at the origin, and I'm going to go 20 meters due south. And then vector v has a magnitude of 20 root 3 and is directed due west. So again, we had 20 meters due south. And then from that point, we're going to pick up with our other vector, and we're going to go 20 root 3 due west. So here's due west, and that's 20 root 3. And now we need to find the magnitude and the direction angle of the resultant vector. So the resultant vector, we need to start where our first vector started, and end where our very last vector ended. And we need to find the magnitude of this. So again, this really looks like those special right triangles. We have a right triangle here. We have the hypotenuse is missing. So if we think about those special right triangles and those values, because we would have had here 30, and this is 60, and we had 1, 2, square root of 3. And to make it a formula, we can just throw an x out here beside them. And notice that it looks like we have a 20 root 3 here. And then our other side is 20, so that looks like the x. So we can reason then that we have a hypotenuse, or the magnitude of my resultant vector is going to have to be 40. Has to be 40. If you don't want to do that, then you can also go through the Pythagorean Theorem and say, well, the magnitude of vector r is going to be the square root of 20 root 3 squared plus 20 squared. And when you work out all of that, you should end up with your magnitude being 40. Now, you need to go through and find your reference angle. Well, our reference angle, or your direction angle, the reference angle is sitting in here. Our actual direction angle, which is what we need, that's going to start here, just like all the other problems did, and it's going to end all the way over here. So let's think about what angle is sitting in here. Well, the angle in here, if we're across from that root 3, is going to have to be 60. So that means this little portion out here is probably 30. Now we need the actual direction angle. So this outside here, that little part's 30, so we're going to have 180 plus that 30. So the direction angle, 180 plus 30, is going to be 210. All right, so for problem 5, let's see what we have for this one. Vector u. So I'm going to go ahead and do my xy axis. Vector u has a magnitude of 15 feet with a direction angle of 30. So direction angle of 30, oh, that looks closer to 45, but we're going to pretend it's 30. And it is 15 feet. And then vector v has a magnitude of 15 feet with a direction angle of 210. Oh, well, we need to keep in mind we have to start where this last one stopped. So I'm going to draw an xy axis to help me pinpoint, well, where in the world is 210 degrees? 210 degrees is right here. And it's really going to retrace our steps. We're going to end up right back where we started. So what would be the magnitude and the direction angle of the resultant vector? Well, the magnitude of that, well, let's think about this. It's 15 minus 15. So the magnitude is 0 because we came back the exact same amount that we went. And what about our direction angle? Well, the direction angle, let's look at where we ended up, right here. So the direction angle, really, if you're right there, it's not just 0, because this case could work no matter where you're at around the unit circle. So really, your direction angle could be anywhere from 0 degrees to 360 degrees. Okay, and then the last one, let's see what we have for this one. Again, I'm going to go ahead and sketch an xy axis. And vector u has a magnitude of 10 feet with a direction angle of 150 degrees. So we're going to draw that over here somewhere. And so we have 150 degrees, so, and 10 feet. And then vector V has a magnitude of 5 square root of 3 feet with a direction angle of 0. So I'm going to start right here. Let's think about where we're at, XY axis there. And 5 root 3 with a direction angle of 0, well, direction angle of 0 is going to throw us right back over here. So let's see what we have here. We need the magnitude and direction angle for the resultant vector. Well, we had a direction angle of 150. Let's see if we can't draw in then our resultant vector. So we need to start where the original started. We need to end where this last one ended. So it looks like our resultant vector looks something like that. So let's go through and see. We have 10 feet. That was the original. And then we have 5 square root of 3 here. And so let's see, can we figure out what that other side would just about have to be? So we have 10 feet, and if we can't see it, now remember your right angle is right here, and we need to find the resultant R. So let's go through, if you don't see right off, the Pythagorean Theorem. So we have 10 squared equals 5 root 3 squared plus that missing side squared. So we have 100 equals, if we square this radical, we get 3, but we also need to remember to square 5. So that's 25 times 3, or 75, plus x squared. And so it looks like my side is going to be 5, which again, if you recognize and remember your special right triangles, then you're going to know that side is 5, and that's quite okay. So I know the magnitude of vector R is going to be 5. Now what about our resultant angle? What's that going to have to be? Well, let's look at it and see. If we start here in standard position and we go to where that resultant vector is, it looks like we're going to end up at 90 degrees. So my direction angle is 90 degrees.